Hello and welcome in to the first video, the content video for lesson 5 for Precalculus 2. Several things we're covering here, so let me just go through the list. We're going to be learning how to go from degrees to radians and radians to degrees. We're going to be talking about something called coterminal values. And then we're going to be looking at a couple different formulas to find arc length, so around the edge of the circle, or sector area, which is like the slice of the pizza. If you have a slice of pizza, how much area is it covering? So let me switch to the document camera here. So it seems like a lot of material, but it's all pretty quick because it's just a lot of formulas and we just have to know how to use it and when. Okay, so the first thing we're going to be talking about is going from radians to degrees and degrees to radians. So again, these are going to be some formulas, probably going to want to have these on your cheat sheet for the exams. So up until this point, we've been talking solely about radians. Um, Now, and I even had mentioned, like if you're doing stuff on your calculator, make sure you're in radian mode. Now you need to pay attention to what is given to you in the problem. So if we're trying to do like some word problems, and not necessarily in this lesson, but a couple future lessons, if it's given to us as the angle is 30 degrees and we're doing like tangent of 30 degrees, we need to make sure that our calculator is in degree mode. If it's given to us as radians, so if it says like what's tangent of pi over 4, if you wanted to do that on your calculator, you would then have to be in radian mode. So make sure that whatever the question is asking, that's the mode that you are in on your calculator. All right, so if we look at that unit circle that we started with on the very first lesson, you see there's these lines on the inside that have the little degree symbol. And that'll be the last thing that we're filling in here. And to do that, we have to know, okay, how do I switch from radians to degrees? So if I have pi over 6 and I want to convert it to a degree, how do I do that? Well, we multiply by 180 over pi. So for example, if I have pi over 6 and I want to convert that to degrees, I multiply by 180 over pi. So the pi's cancel out. 6 cancels out with 180, leaving me 30. So the answer then is that pi over 6 is the same as 30 degrees. Obviously down here we're at 0 degrees. Up top here we're at 90 degrees. Pi over 4, well, this is what? This is cutting through halfway. Halfway of 90 is 45. So pi over 4, switching to degrees, is 45 degrees. And pi over 3 is 60 degrees. And so I'll leave the rest for you guys to do. It's good practice. But then to go the other way. So let's say we're going to see in our formulas today, we have to have the value in radians. But if it's given to us in degrees, we have to be able to switch from degrees to radians. And to do that, we multiply by pi over 180. So let's say, for example, I was given 90 degrees and I want to know, all right, what is this in radians? I multiply by pi over 180. 90 cancels with the 180, leaving me 2. So as we already know, we just saw in the unit circle, 90 degrees is the same as pi over 2 radians. So those are the two formulas you're going to need to go back and forth between degrees and radians. The next topic we have in this lesson is something called coterminal angles. And so, as the name implies, terminal means what? End. And so these are angles that end up at the same place on the circle. So, for example, if I'm over here on the right side of the circle, this is what? This is, we'll do it in degrees first, 0 degrees. But it's also what? Well, if I go around one time, that's 360 degrees. Well, what if I go backwards this way? That's minus 360 degrees. So all of these guys are coterminal because I'm just going around the circle once, twice, because then if I went around twice, it would be what? 360 times 2, 720, and so on and so on. So for degrees, if we want to find the coterminal angle, we just add or subtract plus or minus 360. So if my angle was 30 degrees and I wanted to find coterminal angles, I would do 30 plus 360, plus 360 again, plus 360 again, or 30 minus 360, and minus 360 again, so on and so on. Now, so this is for degrees. What if we're talking about radians? So let's say I'm over here on the right side at 0 radians. I can do what? I can go around the circle one whole time, which is 2 pi. Or I can go again, which is 4 pi. Or maybe I go clockwise, so minus 2 pi, etc. And so, as you've probably just figured out, for radians, we're going to add or subtract 2 pi to the given value. So if I have what's pi over 3, and I want to find coterminal angles, I do pi over 3 plus 2 pi, plus 2 pi again, minus 2 pi, minus 2 pi again, etc., etc. So that is how we determine coterminal angles. They end up at the same spot on the circle. You can see a lot of material, but we get through it pretty quickly here in this lesson. All right, the next one is arc length. So this is if I have some circle, and it doesn't have to be a unit circle, it can have any given radius r. And let's say I want to know this distance here. So if we think back to our original unit circle, we said what? That it's a sidewalk that had radius 1. Well, now what if it's a sidewalk that has radius 5? And if I walk 30 degrees around, I no longer went a distance of pi over 6. I went a distance of basically 5 times that, right? And so we have the following formula. So in a circle with radius r, the length s of an arc that subtends, so kind of a weird word there, but basically meaning goes around the outside there, a central angle of theta. So now let's say this angle in here, we don't know what it is. We're going to call it theta. But here's the key point. Theta radians is given by the following. S, that distance around, is equal to r times theta. but I'm going to write this in red pen here again, just as a reminder. Theta must be in radians. So if you're given theta's 30 degrees, you need to convert that into radians, pi over 6, before you plug it into this formula. Otherwise, if you don't, you will not get the correct answer. So that's arc length. That's the line going around the outside of the circle. And then we have sector area. So now, let's say you and your friends bought a pizza and it's cut into 8 slices. And you want to know, okay, I had 1 slice. So what is the area of that pizza that I just ate? Well, now we have the following. In a circle of radius r, with a central angle, that's the angle on the inside here, theta, the area A is given by the following formula. A equals 1/2 r squared theta. And again, red pen. And I would do the same thing. If you're putting these formulas on a cheat sheet, I would put a note next to it. Theta must be in radians. Because chances are on the exam, because these aren't necessarily hard problems to do. You're just plugging the numbers into a formula, right? So I have to know if you're really know what you're doing. And so for that, I'm probably going to give you the angle in degrees and see if you know that it has to be in radians, or you just plug in the degrees. And then of course you're going to get the answer wrong. So it has to be in radians. And that's it. I know it looked like a lot on the schedule or on the list of what we were covering, and it is sort of a lot. It's 5 topics. So area, degrees to radians, radians to degrees, coterminal angles, arc length, sector area. But that's what we covered here. And so now that you have all that information, we can start working some problems. So come on back to the second video and we'll do a bunch of problems that will utilize what we just learned.